Okay, so momentum practice, formula for momentum is momentum equals mass times velocity. Okay? Remember, mass is measured in kilograms, velocity is measured in meters per second. So my units of measure for momentum are just kilograms times meters per second. Okay? So there's units of measure before we get started. Formula. Triangle, M and V are side by side, so it's going to be side by side in the triangle, P on top. So rearranging this formula, simply M is equal to momentum over velocity, and velocity is equal to momentum over mass. All right, calculate the momentum of a 255 kilogram motorcycle that is moving 44.5 meters per second. Problem solving process. Record your numbers. Kilograms measures mass. Meters per second measures velocity. Question is asking for the momentum. That's P. P equals mv. 255 times 44.5. Calculator says 11347.5. Three significant figures. So 1, 2, 3. That 4 is not going to round the 3 up, so 113 and then 0, 0. So 11,300 units of measure for momentum, kilograms times meters per second. So I have done the first one with you. Each problem, pause and attempt to do the problem on your own. We have a 75 kilograms, 56 meters per second. So the bicyclist is moving 56 meters per second. What is her momentum? Kilograms measures mass. Meters per second is velocity. Question is asking again for momentum. Momentum is mass times velocity. Multiply 75 times 56. Calculator says 4,200. Two sig figs it gave us, so no need to change anything. Units of measure, kilograms, meters per second. Pause and attempt the next one. .92 meters per second. 156,400 kilogram meters per second. Meters per second measures velocity. Kilogram meters per second measures momentum. Question asks for the mass of the truck. Truck is moving with a velocity of 92 meters per second and has a momentum of 156,400 kilogram meters per second. What is the mass of the truck? So mass, this formula for momentum, rearranged to solve for the mass, is momentum over the velocity. 156,400 over 92. That's what your calculator says. Conveniently, your calculator has given you your answer with two significant figures, is what you need. So 1,700 units for mass, kilograms. Next problem. Pause and attempt. $1,200 kilogram car. It's the mass. 76,800 kilogram meters per second. That's momentum. Question is asking for the velocity of the car. Okay, so car is traveling and has momentum. What's the velocity? Momentum is mass times velocity. Formula rearranged using your triangle. Velocity is the momentum over the mass. 76800 divided by 1,200. 64 sig figs, 2, 3, so 2 sig figs. 64 units of measure for velocity, meters per second. On the back side, pause and work the problem. Child rides his bike for 85 seconds with a momentum of 158 kilogram meters per second with a velocity of 3.5 meters per second. What is the mass of the child and bike? Seconds is time. The momentum of the bike with the child is the 158. Meters per second is the velocity. So formula for momentum is mass times velocity. Question is asking for the mass. Okay. So rearrange this formula using your triangle. Mass is going to be equal to the momentum over the velocity. 158 divided by 3.5. So the time was unnecessary extra information. 158 divided by 3.5. 45.142857, blah, blah, blah. Sig figs, 2, 3, so 2. The 1 will not affect the 5, so 45. Units of measure for mass, kilograms, mass of the question. Attempt the problem and work it out. We have 178,000 kilograms. That's a very large truck with its load. Drives at a constant velocity of 56.8 meters per second for a total of 95 seconds. Oh, so here we have mass, here we have velocity, here we have time. Distance, I didn't say that, 5,400 meters is the distance traveled. And it asks, what is the momentum of the truck? Well, formula for momentum is mass times velocity. I have mass, I have velocity. The time and the distance are unnecessary extra information. Multiply my mass times the velocity. And you get a really big number. 10110,400. But that's what happens when you have a really large mass moving very quickly. You end up with a very large momentum. Okay? So significant figures, this one has 3, this one has 3, so we need 3, so 1, 2, 3. That one's knocking around that one up, so 101, 0, 0, 0, 0, 0. So 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. Okay, so 10,100,000 kilogram meters per second. Now something that's worth noting, this is a perfect moment when you use scientific notation. We know the 101 is our significant figures. So 101. And then do the times 10. 1.01 times 10. And I go 1, 2, 3, 4, 5, 6, 7. Times 10 to the 7. 1.01 times 10 to the 7 kilogram meters per second would be the answer with scientific notation. It's a little bit easier to deal with this than that. Less likely to make a mistake writing insufficient number of zeros. Okay. Number 7. Pause, work it out. We have a 120 kilogram baby elephant That's its mass. 0.12 meters per second. That's its velocity. It moves a distance of 15 meters. Question is asking for the momentum. So, momentum is mass times velocity. Distance is unnecessary extra information. 120 kilograms multiplied by 0.125 meters per second. In the calculator, calculator says 14.4. Significant figures, we've got 2 and 2, so 2 significant figures, so just 14 units of measure for momentum, kilogram meters per second. Next problem, pause and give it a try. Okay, so now we have a bullet, something really small. Okay, 1% of it, 4% of a kilogram. All right, but a really big velocity, 370 meters per second, because bullets go really fast when they're shot out of a gun. They travel pretty far distance, 1,000 meters, and it does it really fast, 3.2 seconds. Seconds measures time, meters measures distance, velocity, meters per second, kilograms is mass. And it asks for the momentum. Well, momentum is mass times velocity. We have the mass, we have the velocity. Multiply those. 370 multiplied by 0.040, velocity times the mass. Calculator says 14.8. This has 2 sig figs and that has 2 sig figs, so 2 significant figures. The 14, the 8's going to round the 4 up, so we end up with 15 kilogram meters per second. Now, question number 9 asks you to do a comparison. Okay, so you need to kind of be paying attention to what's going on. It's asking you to compare the baby elephant, which is what we did in question number 7, to the bullet, which was question number 15. Asking you to compare those two. Compare the momentum of a baby elephant. Picture that. Baby elephant. Okay, so no, I'm not the best artist, but baby elephant versus bullet. Explain how these results are possible. Okay, how can this, all right, this has 14 kilogram meters per second, and this is 15 kilogram meters per second. Not exactly the same, but really darn close. How is that possible? So you can figure it out. Okay, how is this possible? Well, let me show you how. We have the elephant, who has a really large mass. But he's going really slow. A really small velocity. Then we have a bullet, who has a really small mass, but going really fast. Very large velocity. Multiplying the big with the small, or the small with the big, that's how you can get the slow yet large elephant has a momentum similar to a small yet very fast bullet. Okay, so there you go. You can do these. You got your calculations down. You understand momentum very well. Make sure you're really, really comfortable with this formula because you're going to need to be able to do conservation momentum, which is next.